In this video, we're going to go over several of the key points of the Mesa Machine competition. The information posted here will be differentiated between middle school and high school. So let's get this started. First thing, so the competition requires the student to propel a vehicle using the power of wind. However, in middle school, the student will be required to propel the vehicle the furthest distance, whereas in high school, the student will be required to propel the vehicle as close to a target as possible. Another difference is in middle school, the student will be allowed to fit the complex machine or the Mesa machine inside a 75 centimeter by 75 centimeter by 75 centimeter cube, which in American units is roughly 2.5 feet by 2.5 feet by 2.5 feet. In high school, however, the student will be required to put the Mesa machine within a 50 centimeter by 50 centimeter by 50 centimeter cube, which is roughly a little bit more than 1.5 feet by 1.5 feet by 1.5 feet. One more big difference is that in middle school, the student will be required to use anywhere between 5 to 10 actions to complete the task, whereas in high school, the student will be required to have at least 6 to 12 actions to complete the task. Now notice for the launch zones, once again, we have 75 centimeters for length, 75 centimeters for the width, and that is the space that the student will be required to place the objects inside for their respective machine. And in high school, it's 50 centimeters by 50 centimeters. Please be aware that the area will be taped on the ground, and for the height, there is that imaginary height of 75 centimeters for middle school and 50 centimeters for high school. Please also be aware that no parts, including moving ones, may extend outside of the launch zone. So for any students wanting to use a fan plugged to an outlet to use as their wind source, that unfortunately will not be allowed. Machine must also be initiated by a single operation outside of designated zones, and the entire body must be located outside, mainly because of safety, because Mesa machines usually work the way that the student wants to. However, it can go awry, and because of that, out of an abundance of caution, student must be outside of the zone. In this picture here, we have an example of a student who is following the rules and being outside of the designated launch zone, whereas we have another student who is not outside the designated launch zone. Please be aware on the picture on the left, the student is reaching out in order to initiate the action for the Mesa machine, whereas in the picture on the right, the student is using a string that is attached to the very beginning part of the Mesa machine, and that will then initiate the marble and have it go down the inclined plane. So on the left-hand example, that would be considered a mistrial, whereas in the right example, this trial would be acceptable. One last thing to note, the initial initiation action will not count towards your 5 to 10 actions for middle school or 6 to 12 actions for high school, which means when the student in the picture on the right pulls that string, that will not count as one of the actions. Secondly, there needs to be a physical string or some type of wire that connects the student's arm, which is located outside the zone, to the very first action to start the machine. This means that any wireless signals to initiate the machine will unfortunately not be allowed for this experiment.